All right, so we will go ahead and get started. Hi, everyone. My name is Ben Porter. I am one of the instructional faculty here in the Bioengineering department at UT Dallas. I'm also the Student Success Coordinator for the department. And tonight you're stuck with just me, but I know the topic fairly well, so we'll cover it the best we can. If you could, you're free to you're free to ask questions at any time. Raise your hand, type in the chat, however you'd like to do it. But if you're not asking a question, if you wouldn't mind leaving your microphone or your cameras off, that will help to avoid confusion and cause some lag. We are also recording this, so if you'd rather not be known, your name, you can ask questions in the chat and that won't appear. But if you turn on your camera or your microphone, that will appear. All right, well, let's go ahead and get started. So this is the third of our summer welcome series, and our last one, we had a welcome from many of the people that you would want to know or should know within the department and within the School of Engineering on our first event. And then we had two panel discussions, one from faculty and one from students and alumni on tips for student success and what you can do to make the most of your time here at UTD. Those are all available on previous videos, which you should have seen on the last email I sent. You should be hopefully getting used to all those emails by now. They'll keep coming, don't worry. But I will send those out again when I also send out the video for this one. I do want to remind you, we have our boot camp coming up. That's going to be a live event. It's our Bioengineering Academic Boot Camp. It's a series of talks and workshops. Well, you can read that. I'm not going to read it out loud, but basically, we're getting together with a bunch of other students and faculty who have already been through all this, and they're going to give tips. I don't know why it's advancing. Tips and suggestions on how to make the most, again, of your time in bioengineering, but also just how to be a good student. And I don't mean just a good student, but how to be a good college student, because that is different from a high school student. Or even from a transferring in type approach to classes that you may have taken in the past. So it can be very useful. I suggest if you have the time to go ahead and come by and visit with us. It'll also be a great chance to meet with some of the other students who will be in your cohort, which is very beneficial as you go throughout your career. But that's all. It's not required. I'm not going to make you, I'm just going to judge you. I'm kidding. I'm not going to judge you, but you should come. Okay. Anyways, on to what we're talking about today. So we're going to discuss basic schedule. What is bioengineering? What is biomedical engineering? What kind of jobs and careers can you look for in bioengineering and academia and research, or medical device support, which is also what we would refer to as industry, and in medicine? And then we'll have some time for questions. So if I don't have any questions, I'm going to jump right into what is bioengineering or biomedical engineering. So the reason we want to cover this, a lot of students come in and they don't necessarily understand or know what bioengineering or biomedical engineering is. And I mentioned in the very first talk that we had that bioengineering is very broad. We are the Department of Bioengineering here at UT Dallas. Bioengineering, though, encompasses a lot of different things. It can encompass making fuel out of algae is the one I always think of. It could also be making GMO crops or things along those lines. Biomedical engineering is a very specific branch of the bioengineering. We look just at medical applications, whether it be for humans or animals, but we focus on that biomedical side. So what that can encompass is quite a bit. Biomedical engineering does lie at the intersection of engineering, biology, and medicine. But it requires an education that is entrenched in mathematics, chemistry, physics, engineering design, the life sciences. This Venn diagram, which took me a little while to make, it's not very easy, and don't look at it too carefully because it's not perfect. But we are at the center of all these different fields. It is very cool because you can now speak all these different languages. You can speak to biologists as well as you could speak to engineers, as well as you could speak to somebody who's doing programming. It makes for very valuable employees because you can translate these different languages, if you will, right? Because you can speak from you can talk to the CEO in the company and explain the engineering aspects of things that they wouldn't necessarily understand and that the engineers wouldn't necessarily be able to explain very well because they don't have that communication understanding, which you will get. So biomedical engineering is a very cool discipline. I tend to get very excited about it. So what do bioengineers do? Well, very broadly, a lot of different things. So this does not encompass everything, but we'll go into a little bit of each one of these. So biomechanics, that is looking at how the body interacts or how it works. So if I'm looking at how the heart beats and the actual mechanics of that beat and trying to figure out how to use that in creating new things, just things in general, that's part of biomechanics. On the flip side, biomechanics is then trying to figure out how you can have devices interact with the body in a mechanical sort of way, right? I feel like I just used the word in the definition, but that's still basically it. Okay. Now, prosthetic devices and artificial organs are somewhat different. Prosthetic devices, those aren't necessarily just the mechanics. Biomechanics is looking at the actual mechanics. Prosthetics is the actual device, right? So if I'm going to replace the lower half of my leg, it's designing that actual device. So it does interact with many of these other fields. Yes, absolutely. But it is more just on that prosthetic part. Same with the artificial organs. So figuring out how to make an artificial organ work that is just as good as the natural organ, the organ that you're born with, right? Medical imaging, that can be anything from x-rays to fMRIs to PET scans to ultrasound. We use a lot of ultrasound within the department for various reasons. But anything pretty much that takes a picture of the inside of your body is medical imaging. So biomedical engineers work on developing new technologies that can do that, or improving the existing technologies, or using those technologies and those images to do new things. So figuring out how can you actually diagnose illnesses using the images that we have. Biomaterials looks at the interaction of materials with the biology. So if I'm going to put an implant in the body, how do I keep my body from rejecting it? What kind of material can I use that's not going to just be kicked out of the body because it's not something that's natural, right? Biomaterials does also include studying materials from the body that you can then use. So it's similar to biomechanics in that way, but think of it more about kind of how the body interacts with different materials. Biotechnology, that one, wow, I just completely drew a blank on what biotechnology is. That's crazy and embarrassing. Similar, yes, okay, so similarly to biomechanics, biotechnology is figuring out how to use the body and the physiology of the body in new technologies. So it's less on the mechanics, but more on the technological aspects of how can I apply things that occur naturally in the body to non-biological things. Okay? Tissue engineering, that is involved with making new tissues, how to grow the tissues. So you've seen the artificial organs, or maybe they're growing the artificial ear on the back of the mouse. You may have seen that picture. It was pretty famous for a while. It's along the lines of tissue engineering. Neural engineering, it's like neuroscience, but you're not really trying to figure out how the brain works necessarily, as more how to interact with the brain. So think about putting brain probes in. And this is the sort of thing where you see a paraplegic who can't move, but using a probe in their brain, they can move a cursor on a board. And it's not just trying to figure out how to make that interaction, but how to make that interaction better. So how do you develop the biomaterials that can go in the brain that aren't going to get rejected or damage the brain, because the brain is constantly moving, right? And if you have something that's stationary in it, it's going to hurt the brain. So neural engineering encompasses a lot of that. And we do work a lot with our neuroscience on that. Biomedical instrumentation, it's kind of exactly what it says. It's developing those new instruments for surgeries. So it's a great one there. Bio-nanotechnology, it's trying to apply all this on a very small scale. So the best example I can think of a bio-nanotechnology that we have going on here is the use of microbubbles, which are really, really, really tiny bubbles, micro, you might even say, using those to deliver drugs to different parts of the body. So you have these little tiny bubbles going throughout the bloodstream. They don't hurt because they're these really small bubbles, so it's okay to actually put them in the bloodstream. But you can deliver to a very specific place by using ultrasound to then burst those bubbles. So Dr. Shashank seriously works on that technology, which is really cool. Physiological modeling is figuring out how the different parts of the body work. So the one I can think of that is Heather Hyenga. Dr. Hyenga models the heart and how it is working. And by using the physiological models, you can see what is working well, what is not working well. But then you can predict disease states using that physiological modeling. So that combines well with medical imaging. Rehabilitation engineering is figuring out the actual rehabilitation that comes with the prosthetic devices or many of the other things. So how do we actually use these things that we've engineered to make people better? Medical and bioinformatics is looking at mass data from a lot of the medical studies and combining it and basically just using different aspects of a person or their life to then make predictions about what could be possible health problems that they have to watch for. Clinical engineering is a very hot field. We're going to talk about that one a little coming up here. But that is, if you are in the hospital, how does a hospital know what MRI machine to buy? Right? There's not just one, there's multiples out there. So how do they go out and do the comparison shopping to pick the best one? That's the clinical engineer's job. So they talk to all the people in the hospital, all the people in the clinical setting, figure out what it is that they need, and then you can think about that as they actually apply that technological savvy to get the best device. They do more than that, but that's for now, that'll be a good description. Biosensors, you can also think these as the lab on a chip. The smartwatches everybody wears, right? They'll tell you your heartbeat. That's a biosensor. Doing the I just totally forgot it, but the thing that you put on your arm, it's a patch, and it'll tell you your blood sugar level. Abbott makes one, right? It's for diabetics. That is a biosensor. One of our faculty, Dr. Prasad, who is our department head, is trying to develop one that doesn't actually require needles, so it can tell your blood sucrose level through your sweat. I guess it's not the blood sucrose level, but it'll tell you sugar levels through your sweat. So that sort of thing. Or you think about COVID-19, the swabs that were developed, that's a type of biosensor. So lots of things going on there. Medical and biological analysis, that one's just kind of a catch-all, honestly, but analyzing a lot of the medical and biological information that's out. So that is a lot of information, right? I just went through this entire slide. Probably took me like, what, 5 minutes, maybe even longer. So bioengineering is broad, very, very broad. Is the gist of that. Now I'm going to put in a slight plug here. I'm not going to really hit on doing research at UTD because that may not be a field that you decide to do. But even if you're not interested in doing research, it is a very valuable experience. And we here at UTD, especially in the bioengineering department, try to encourage students to do research as much as they can. Reasons being, you do get that enhanced career preparation. So you're actually working in a setting that you have to be professional in. So you have to show up on time. You have to conduct yourself professionally. So it is showing that you do have at least that experience. It does help you to prepare for more rigorous careers in research, if that is something that you're interested in. And if nothing else, if you get into it and decide that you don't like research, that is a very valuable experience. Getting into something and realizing you don't like it and then figuring out why is extremely useful. You do get increased skills, no doubt, and aside from the obvious research skills that you get doing research. Working collaboratively as part of a team, that's something that always comes up in interviews when it comes time for a job. Same with communication. Leadership, there's multiple opportunities for leadership, and the longer that you are in a lab, the greater opportunities you get towards that leadership or even publishing your own research. The critical thinking, that's what engineers do, is critical think and problem solve, and this is definitely one of those chances where you get to use that. And then the soft skill development, because you are interacting with other people. You are interacting with someone who's basically a boss for you, right? You do get that increased understanding of the research process, which is very beneficial. You get to see how engineering works. And not just engineering, but engineering research, which is just great. It's really useful. You have that shift from passive learning to active learning. So passive learning, meaning you sit in class, we talk at you, We try to get hands-on as much as possible, but sometimes it's not very interactive, right? It's just you're sitting, you might be reading from a book, it gets kind of boring, blah, right? Not to say most classes are like that. We try really hard to make them not. But that's the more of the passive learning. The active learning, you get to go into the lab and actually do things. So that is it is a lot more hands-on. It is a lot more being active in it and having an active role in your education, which is cool. And then becoming a part of a learning community. Yes, and that's a thing too. I would also say, so we like to see students get internships and we like to see students do research in a lab. Our dean actually recommends you get an internship one summer, you do research in a lab one summer, and you try to study abroad one summer. Of those three things, doing research in a lab is probably the easiest to get into. I'm not saying that it is an easy thing to do or that it's bad because it's easy to get into, but it's probably the most accessible thing to you. So I would definitely pursue that as a way to differentiate yourself. Okay. One more thing on undergraduate research, and then we'll move on. There are multiple ways you can get involved. So bioengineering has close to 25 faculty in 6 different research areas. And I already described a bunch of these earlier, so I'm not going to do it again. We have 3 brand new faculty starting this fall. They are going to be looking to develop and staff their labs with volunteers. They need help for sure. They may not need it exactly in fall, but they will need it starting in probably more in spring, which is about time that you would really want to start looking for that research experience. So those are going to be people to watch out for. You can volunteer at any time, meaning you don't have to wait for a summer experience or a winter experience. You can start in the middle of the semester, whenever really is convenient for you and the faculty member that you want to volunteer with. Most labs do require that minimum of 9 hours, so you want to make sure that you can commit the time. And if you've been in the past talk, you know that I personally recommend that you wait through that first semester before you start volunteering, just so you can see what it's like in college at UTD before committing to further commitments. Well, way to use the word twice. But before taking on those extra responsibilities, right? So make sure that you can handle it before you take something else like that, because it is a decent chunk of time in your week. We do also have what we call our STARS program. That's the Summer Training and Research Scholars. We just wrapped that up last week and a half ago. It is over the summer. It's 10 weeks of paid research. So you get to go into a lab, you're paid to be there, you get the stipend. You get your own project, and then at the end of it, you get to present a poster on it. And depending on how that goes, you can usually go to a conference, or if you continue doing work in the lab, that can lead to publications, which is really good. But you do get that one-on-one with the graduate student mentors and the research faculty. So that's a really good experience. That application process for that opens up in December. So you can keep an eye out for that. You also can participate in undergraduate poster competitions. We have one every November where students get to present their research. So that's a great one. You can do conference presentations. And if nothing else, if you don't really want to join a lab, you don't think you have time for it, but you are still interested in hearing about the research, we have weekly seminars basically for the entire department where you can come just listen to research that's going on. Sometimes it's at UTD, sometimes it's at other schools. If it's from other schools, usually we try to bring in some of the big cool people who are doing awesome research as opposed to not awesome research. But that's a great way to learn more. You may only understand half of what they're saying, and that's totally fine. The more you go to them, the more familiar, the easier they become to understand that scientific talk. You can also ask just to attend certain faculty members' lab meetings. If there's somebody doing research that you're really interested in, but you're not ready to join their lab, you can ask if you can sit on their lab meetings. Most of the time, they have no problem with that as long as you're not causing problems, which would be where we cause problems. But that's a great way to stay up with what they're doing. And then when you are ready to volunteer with them, you've already been to their lab meetings. They already know you. So it's a good way to get your foot in the door. Okay. I've talked for like 15, 20 minutes now. Any questions? Give me a chance to take a sip of water. My microphone on? That would really stink. Hmm. Tough crowd. Tough crowd. Okay. Moving on then. Let's start talking about, oh, wait, no, there's one. Switching majors to what? Yes, you can. And I won't hold it against you if you're switching majors. That's okay. You are not restricted based on your major to what labs you work in. Electrical or mechanical can work in bioengineering. Bioengineering can work in biology. Really, they can go wherever it's useful to you. So it is seeing what fits in best with that lab. Will this meeting also be a video? Yes, it will. So we are recording this as well. Okay. So let's start talking about what you can do with the degree. Oh, do all professors offer sit-in meetings? So usually it's a tenure track faculty who is going to have a lab and doing research. Instructional faculty such as myself, we don't do research, so we don't have lab meetings. But anybody with a lab usually has lab meetings. So for them, yes, they do have sit-in meetings, and you can ask to join those. Specialize in a department in bioengineering early on or later in the year. Um, I, if I understand correctly, I'm thinking you mean the different research areas. You can start off pretty broad and specialize later on. I would recommend getting a touch of everything and seeing what it is you like. And that's actually part of the reason that we do the BMIN 1100 class is to expose you to those different research areas so you can see what they're all like. Um, you kind of want to wait to specialize until after you've seen what they're all about. Um, that doesn't mean that you don't want to join a lab in biomechanics in your first year and then switch later to systems biology. That's fine. You're really part of the whole point of college is figuring out what you want to do. So you just got to do it right. But yeah, you can specialize early, you can specialize late. I recommend specializing late. Cool. All right, let's move on. Keep the questions coming if you want. And if I don't see it, make some noise and we'll come back to you. So what can you do in academia and research? This is just a convenient segue. There's a lot more that you can do than just academia and research. So don't be discouraged that I'm going straight into that if you don't like research. One of the more obvious ones is high school teachers. They're in demand, no doubt. You do need a BS or a BA. Usually there's a teaching certification that's required. The median salary is currently lower than it should be, as anyone will tell you, but there is a lot of outlook for it. It's 8% growth. Now, the nice thing about teaching is you, as a junior or senior, can become a substitute teacher. So yes, you can. You can become a substitute teacher in your junior or senior year while you're attending college, especially the STEM teachers. They love us. And that's a good way to get some supplemental income if you need it. So keep that in mind when you get later on in the years. And it's also just a great experience, especially if you think you want to become a teacher. Okay. Now, personally, I could not become a high school teacher or even earlier because I don't have the patience for it. I'm much better with the post-secondary teaching and professorships. So y'all are about right for me. It's about the good age. I can deal with this. I'm good with these students. With you students, I don't like the way it's coming out. We're just going to skip over that last part. You do typically need to have a PhD to be a college professor. Few exceptions. If you were to go to a community college, you might get away with just having a master's. But typically, you want to have a PhD for it. The median salary does start about 80,000. It's usually a little bit higher. That's the median salary for all post-secondary teachers. So that includes like your arts and humanities, but STEM teachers tend to get paid more, especially in the engineering field. And that is a high outlook career. All right. Now you get to your tenure track, tenured faculty. So these are the people who do research. These are the ones who have their own labs and keep that going. So in addition to teaching, they have that lab commitment that they're supposed to do. So they are designing experiments. They are increasing the knowledge in the field. They do spend a lot of time applying for research grants and trying to publish what they found. So there's a lot of writing involved if you ever become tenure track or tenured faculty. I think that can tend to throw some people off. You do have to have a PhD for that, and you do have to have research experience and a record of publications and grants. Median salary starts around 108,000. That again is for all tenure track faculty. STEM tends to be higher. Engineering tends to be higher. Job outlook is a tough call right now because, well, it just is. um, Colleges are seeing a slight shrinkage right now in enrollment, except for UTD. We're up there because we're awesome. Um, but that fluctuates, so it's hard to say on that one. It is very competitive to become a research faculty. Um, if you don't like the writing aspect so much and you really want to stick more to doing the research side of things, there are definitely jobs still out there. So if you look at a lab manager, this is a person who it is their job to run the lab, to keep the labs going. Sometimes they'll be running a lab for multiple people. Sometimes it's just for one faculty member in particular. Um, but the median salary on this is about 129,000. There is still growth with this. You do multiple things. So it's not just running the experiments, but you are managing it. You are training new people. You're taking care of the equipment, safety, and the maintenance. So there's a lot with lab managers. And this one's not just in academics. This can go outside of academics as well. Research support. This is a terrible description, but we'll see if we can expound on it a little bit. So you make sure all the information in research databases are up to date and accurate. You're basically wrangling the data as research support. So this is where it comes really in handy to know about statistics and how to use a database. So this one, BS is good to have that bachelor, but usually I do prefer somebody with more experience, like the master's and the PhD. Median salary again, about 97,000. The job outlook on research support, I imagine, is fairly close to the same as a lab manager, because this is one of those ones that you can get outside of academia and do. So you can go into industry, and this one still applies. This one overlaps with industry fairly well. So research and development engineer, and I think this is what a lot of people think that they're going to be getting into when they join into biomedical engineering. But this is the person who designs and tests the new products. So you want a new artificial heart, research and development engineer is the person who's going to put it together, right? So they make all these other parts and they go through that full engineering experience trying to get up and running. You do only have to have a bachelor's for this one and experience. So you can't immediately go into R&D thinking that you are going to be the person who designs an entire artificial heart. They're not going to give something quite that big to someone who's just starting off. Instead, if you're trying to go into R&D, you have to build your way up. So instead of thinking that you're going to do the entire artificial heart, think that you're going to start with like designing a screw or something like that, right? And build your way up. So it is a process. That job outlook on this says 4% growth. We are seeing medical devices grow a lot, as you can expect. So I would expect that to be going up. And 4% is actually good. That's normal. So that's a good growth rate. When you get to the senior research engineer, now you're going to be overlooking multiple projects. So you may be the person who's putting together and combining everything into that artificial heart. Or maybe you're looking over 2 models of the artificial heart, something along those lines. This one comes with more experience as well. So that is a very, very quick overview of the research and development side of things, or the academic side with research. I'm going to start moving into medical device support. Any questions about anything we've talked about there? There is more out there. There's a lot more out there. I'm just covering some very basics, trying to get your feet wet for you, splashing some water on you. It's all very cool. Okay, but wait, there's more. So, okay, let's talk then about medical device support. And I'm using this as a catch-all phrase, really. So this is more looking at industry. And this is the one I think a lot of people don't realize how many jobs there are out there. So looking straight into it. So regulatory affairs. You will learn a lot more about regulations as part of your major. But think about it, anytime that you have like an artificial heart, you don't want anybody just designing it, right? It needs to be safe. If you're going to put an artificial heart in me, I want to make sure it's not going to kill me, or that I have to replace it in 2 years. or that it's going to have a toxic material, it's going to give me cancer or something like that, right? So that's how we have medical device regulations. This is set up by the FDA. There are certain rules that need to be followed whenever these devices get made. And there's tests that have to go through, and there's different systems that have to be set up. So lots of different things that go into it. They need people who understand the engineering aspect and can learn the regulatory aspect of it. So these do tend to be those 9 to 5 jobs, and they do tend to pay fairly well. And if you are good with regulations and working with applying those regulations, this can be a great job. And so regulatory affairs, there's room for growth in it, and there's a lot of different aspects to it. So there's not just the US, but there's regulatory affairs. If you were going to go into a company that's working internationally, most nations have their own version of those regulatory affairs that they have to take care of the regulations that they have to take care of. So there's a lot of growth in this one too. So that's the regulatory side of things. We also have quality engineers. This is different from this is quality assurance. It's not quality testing. Quality testing is a thing, but it's usually doesn't require nearly as high a degree. But quality testing is when you go out and you're like, is this pencil going to break? Yeah, it broke, right? That's quality testing. Quality assurance is making sure that you are creating that same type of pencil each and every time, and that it has that same breaking point each and every time. So quality engineers, they're responsible for making sure that your medical device that you're creating, that artificial heart, is the exact same or as exact as it possibly can be each time, and that it's created safely each time. So this is another fairly hot field right now. Quality engineer used to not be a thing. It's a fairly new job that's out there. And there's very few. Usually it's more on the master's level that you could actually get into if you wanted an education in quality engineering. But being a biomedical engineer sets you up well to go into this field. I'm not sure I explained that very well. We have a lot of students who go into quality engineering. It's another one of those really cool areas. Okay, so I talked about regulatory side. You have the flip side, which is the FDA, which is trying to enforce all those regulations. So they need consumer safety officers who go out and actually make sure that all of the regulations are being met, that you are actually developing your medical device in the correct way. So the consumer safety officers, they actually can start off fairly low. I've actually found the salary range on this one from anywhere from the mid 50s and up. But the mid 50s, I think that's more along the lines of your food inspectors. Medical device inspectors, I understand it, get paid more. And it is a quick, working for the government is actually a pretty sweet gig. It's a nice job. It's pretty secure, and it's a 9 to 5 job for sure. But the consumer safety officers, they go out and make sure that the regulations are actually being followed. There's opportunity for travel with this particular position, and there's also a lot of room for growth in it. Medical device sales reps. So if you are a person who's a natural salesman, this can be a good way to go. 125,000 is again the mean, but the range on this, it gets really ridiculous. So it really depends on how good you are at sales. They need people who understand the engineering aspect of it so they can go out and talk to medical doctors and say, this is how this works, right? So that they can answer those technical questions and actually discuss the way like the artificial heart will interact with the body in an intelligent way that makes sense. So you have to have that engineering background really to do this job well with medical devices. It helps if you have those other sales aspects that you like or that you're good at. But this is definitely a good field that is out there for people. Okay. Patent. So this is intellectual property. I've made my artificial heart. Now I don't want this other company to be able to take my design and also make it and sell it after I did all the work to develop it, right? So I make it patented, meaning that they can't make it. I'm the only one who gets to make it. When I file a patent with the USPTO, the Patent and Trademark Office, They need people who understand what they're looking at to read the patent and say, yeah, this is good, right? There's not another patent out here that exists that this is replicating, right? Um, so patent examiner, it's another one of those ones that's in high demand, and they especially like students or employees who come from STEM backgrounds because you need that engineering background really to understand it. So patent examiner is another one that we really like to send students into. Um, on the flip side of that one, you have your patent attorney. So sorry, let me back up just a second. Patent examiner, you can almost immediately go into this. Actually, you can go into the patent examiner straight out. There's a step in between that you take a test. It's not your bar. It's like a mini bar on patents. Okay, mini bar, like a mini bar exam, not a mini bar. That focuses just on patents that you can get a good job with on that. If you take the full bar exam, you can become a patent attorney. This is another one of those careers where the salary can just go huge on it. And it's in high demand. It's a pretty cool job. So this is the one where when I had my artificial heart and this other company made their artificial heart, it looks exactly like mine except they changed the color, and I want to get after them to stop making my artificial heart that they just changed the color on. That's where the patent attorney comes in. So this is another one where you need to be able to understand the engineering side of it. It really helps to understand the engineering side of it, and then be able to apply law with that. All right. So the last section I was going to jump into here is what can you do with the biomedical engineering in medicine? One of the more obvious ones that many of you are probably planning on is the pre-med route. So you can be a medical doctor, dentist, veterinarian, and basically fill in the blanks. So blank, diagnose and treat problems with blank, whatever you want to put in there. Median salary, this is another one that varies wildly. For an MD, about 200,000. Then 160 for your dentists, or about 100,000 for vets. The demand is actually really high for vets, which I found a little surprising. Medical doctors, it's also fairly high end. It's just a little bit tougher to get into. So remember, in the past, we've said that this is most definitely an engineering degree. It is not a fallback degree. So if you're going into it planning on using biomedical engineering as a doctor, that's a good plan. If you're thinking that, oh, well, if I don't make it as a doctor, I can fall back into biomedical engineering, that's a hard plan because it is a very demanding degree. So don't let me discourage you too much, but just make sure that's understood. Okay. Now, that clinical engineer I was talking about, this is a very high demand job right now. They need people who understand the technology in hospitals. Oh, hard in what way? The degree is hard in that, so back with the MDs and DDs and all that, biomedical engineering is a full-on engineering degree, so you do have to do all the math, all the calculus, understand all of those aspects. You still have to take the hard classes like thermodynamics, and those other really hardcore engineering classes. But on top of that, you're also now trying to understand your physiology, biology. Not trying to discourage you. That is part of what makes it such an interesting degree, but it can be a little tough. So if you're planning on doing biomedical engineering and doing your preparation for being pre-med as well, it definitely can be done. A lot of people do it. But it is more challenging than if you were to say just go into biology instead of biomedical engineering. Does that make sense? Does it not make sense? Okay, cool. Again, I'm not trying to discourage you, just trying to kind of be open to eyes here. Okay. Clinical engineering, I mentioned buying devices or buying equipment. They also are in charge of making sure that the equipment is working, not necessarily I'm going to go do the repairs myself. They can, but usually that's more a technician's job. The clinical engineer is more going to deal with recalls. So if we have 500 infusion pumps and there's a recall on it, I have to make sure all 500 infusion pumps come back get fixed, and then go back out. So it may be a technician who's actually doing the fix on it, but the clinical engineer is the one who's in charge of making sure everything actually gets done. So they interact with a lot of different people. It's a great way if you want to interact with doctors, but don't want to be the person practicing medicine. It's a good job for that. Um, they also have to interact with the nurses. They have to interact with sales reps, and I'm drawing a blank, but they are highly involved with a lot of different people, and there is a lot of growth potential here as well. Yeah, I actually think clinical engineering sounds like a really cool job. If I were to go back and do it all over again, that'd be one of those ones I'd really consider. Okay. Still on the clinical side, you have something called a clinical research associate. So we mentioned that for the FDA, you have to go and follow a bunch of regulations, right? Some of that is to get your medical device tested in patients. So if I'm doing an artificial heart before I go sell it out to the masses, I want to make sure in a smaller subset that it works properly. Now, I've already tested it to make sure that it's pretty safe before I put it in people, but I still need to go put it in a subset of people and have it tested even further before I can sell it on the market. Clinical research associates run those tests. So they're the ones who are running all those clinical tests. There's a lot of documentation that goes into it. But if you're interested in doing a job that works with patients directly, this is one. You still get to interact with the medical professionals, so the doctors, the nurses. You're still interacting with the engineers. You're interacting broadly. And if you can do a clinical research associate well, there's a lot of opportunities there. There are what are called CROs, clinical research organizations. That is their sole thing that they do. So they'll have clinical research associates and they'll hop in between different companies and do the testing for them. And it can be very lucrative. So yes, that's another one to think about, clinical research associate. If you're interested in doing clinical studies, great one to pursue. Okay, medical science liaison. So this is similar to your sales rep that we mentioned, except you're not doing sales. You are now the absolute expert in whatever field it is. So again, artificial hearts, then I am an expert in artificial hearts. I usually have to have a PhD or an MD, one of those higher degrees in this. But your role is to go out talking with the physicians, talking with your key opinion leaders there that it's mentioning, and figuring out what is the next best thing to develop. Staying up and it really is kind of cutting edge because you are staying up on all of the research that's going on in your particular field. You are trying to keep your company one step ahead of everybody else. So it's not really sales, but you are interacting with a lot of people and you have to have that scientific expertise, that engineering expertise. So 147 is a low starting number. It can go high, it can go very high as well. I think I have one more. Orthotist or prosthetist. I don't think I said either one of those words right, so please don't quote me on that. High in demand though, so people that can fit prosthetics. You got to make them, you can fit them. High demand field. A lot of students come in very interested in this. It is most definitely a career option and is 18% job outlook is incredible. So you may have to go get a master's to be able to do this well. But you can at least start getting your foot in the door as an undergraduate. Okay. That is a lot of different jobs we talked about, probably between 25 and 30 different jobs. So hopefully that was a good exploration for you. Do you have any questions for me? Anything at all? Jobs, life? I don't know. Why is it so dark in here? It's because I'm sitting in front of a window. It's kind of a boring explanation. Could I name some possible companies? Oh man. I actually just sent out our first email requesting companies for our career fair in September. I think I sent it to about 50 different companies. So Abbott and Alcon and Stryker, they're all three big ones that we have in the area. Alcon, from contact lenses and various other eye-related devices, really. Contact lenses are a device. Abbott, we have neuromodulation here, and we also have, I believe they work on artificial hearts. Stryker, I'm not so sure about. Those are three of the major ones. And then there's a lot of medium-sized companies, and we have a lot of startups in the area which are kicking in, which is pretty cool. Okay, see more questions coming in. Sorry, that's just a couple of companies. If you want, I can send you a list if you remind me. But there's a lot out there. You can look at our past career fairs too to get lists for that. All right, is it possible to see other major jobs too? How do you access those webinars? So that is a good question. How do you compare to other jobs or other engineering jobs or other engineering fields? I don't know that other degrees are doing these summer webinars like we're doing. I actually think we are the only one. But you can go out and look at the professional websites, the professional organization websites that they have, like IEEE for the electrical engineering. Mechanical engineering has a professional website. Sorry, I'm getting tired. I'm not talking well. Mechanical engineering has a professional organization. I can't even think of the right word. Society. Sorry, the Society for Mechanical Engineering. I'm not sure what the actual title is, but when you go to those, they will have a place that you can do career exploration. So it's not just a job board where you can find actual jobs that people are currently looking to fill, but you can see the different options. Another place that you can go to, which is a great resource for finding out about careers within these different degrees, is glassdoor.com. You usually have to register with them, which is just giving them an email address, and they'll spam you. But it's a great resource, so you can go there, and actually that's where a lot of this stuff comes from. Like anything where you see where it's glassdoor.com, if you go and you look up clinical research associate and do a search for the career as opposed to jobs, it will tell you all about it. So you can go look at mechanical engineering that way, or electrical, or whatever other degrees you're interested in. If you find a job interesting, could you intern at companies that offer it? Yes, most definitely. The tricky part, it's not even the tricky part. The challenging part is finding the posts for those internships or convincing them that they need an intern. So finding the internship can be a little bit challenging, but yes, you can definitely intern at any of the companies that offer one. I'm not sure if that's exactly what you're asking. Ask again if that's not catching it. All right, so elaborate on what I meant by get your foot in the door. I remember saying that. Which one did I say that with? I don't remember which job I said that with. Getting the foot in the door, it's a great, oh, the prosthetic slide? Okay. Oh, right. Okay. So getting your foot in the door, there are a couple companies in the area that work on prosthetics. If you can get an internship with them, or if you can just start talking with them and networking with them, by getting your foot in the door, I mean, they now know you. So you may not necessarily have that master's, but they're looking for, but they are aware of you, and it helps with your future job options. So that's what I mean by getting your foot in the door is making them aware of you, getting that reputation with them ahead of time. So really, you're looking for that opening, any sort of opening you can get that makes you stand out from any of the other job applicants. So that's what I mean by getting that foot in the door. So thank you for the reminder on that one. Jobs that require a master's, would you need a master's in biomedical engineering, or can it be any engineering discipline? That is a really good question. With a really unsatisfactory answer of yes. So it can be either one. The way I typically recommend to people when it comes to getting your education, if you're going to get a master's, the challenge with being a biomedical engineer is also the benefit of being a biomedical engineer. And that's what we covered on that first slide. You have to know a little bit about everything and kind of be able to speak all these different languages, which is great. one of the common complaints from companies is that they don't think our people are necessarily as specialized as an electrical engineer. And we talked about this in some of our previous videos too. Um, that's not necessarily a problem. It's just you get to educate them. So you can do that if you're just getting a bachelor's. You do that by specializing in those things that you become interested in. So if you really want to go for a job that's electrical engineering within biomedical engineering, then you seek out the opportunities that'll let you demonstrate that you work on that electrical engineering side. So you go find the projects that are more electrically engineering oriented, right? Or you try to get the internships in those companies, or you go join a research lab that's doing electrical engineering. So those things that help set you aside. When it comes to getting that master's, if they're doing if the job is really focused on one aspect of it, then it can help to get that master's in electrical engineering instead, right? If I want to go work for TI, which is really heavily in electrical engineering, then I might want to go get my master's in that instead, right? So I can get the biomedical as an undergraduate, get the master's as a graduate to show that I have that specialization, or vice versa. You get the electrical as an undergraduate and get the biomedical as a master's. If you are going into a field that is medical, I think the biomedical engineering is a fantastic way to do it. It's just you have to be able to differentiate yourself. So again, feels like I'm rambling, but really it just comes down to being able to show that you have that specialization. All right, that didn't answer your question well enough. Please feel free to keep typing and I'll come back to that. Okay. Next question, where on campus do you come and meet on the 18th? Ooh. So it's called the TI Auditorium, and I'm actually going to break from my slides, which feels wrong, but I'm going to do it anyways, and bring up a campus map if the campus map's working. I was having some challenges with it earlier. Oh yeah, okay, cool. All right, so let's orient you a bit. If you've never been on campus, then I'm probably going to lose you anyways. I'm going to try not to. So the main entrance to campus starts down here off the Campbell. You have the nice trees. It's really pretty. You come up here, we have the circle. Over here, we have the activity center / bookstore / the welcome center thing where we give all the tours and everything from. And then the nice parking lot here. Engineering is spread out across 3 different buildings. Let's zoom in a bit here because that's kind of really far out here. You have the Engineering North, Engineering South, and Engineering West. So it's ECS North, ECS South, ECS West. Most of your classes will probably be within these 3 buildings. For bioengineering, you will also be in the modular lab 1 over here for at least Beeman 1100. So hopefully that's helping to orient. You also have your student union over here. So that's where we have the Chick-fil-A and all the food. So just down this main drag is how you get to all these other buildings. Now, inside Engineering South, actually right there is the TI Auditorium. So let me switch views over here really quick. We go to our administrative. Let's say we're going ECS South. Yeah, this is really handy for when you're trying to find your classrooms for class on the first day, right? You have the room locator. Click on that. It gives you a map of the buildings, which is really nice. So you can go to the different floors. And don't pay attention to if it says it's the 2nd floor or the 3rd floor. For some reason, it says the ground floor of ECS South is the 2nd floor. Doesn't make much sense, but just go with it, okay? This is the TI Auditorium. So when you came in, you were parking over here at the gym, the activity center, or the bookstore. You just come up. You have Rutford, which is the pedestrian walkway, and it's the TI Auditorium right there. Okay. Another good reference to come from is over here is parking structure 4, right next to ECS West. So when you come out of parking structure 4, you cut across. This is a sidewalk. Come across, come down, enter in there, and there you go. Since we're on the map, I'll give you one more thing here. In ECS North, So ECS South and ECS North they're kind of one building. I don't know why they split them into two, but they are connected by a hallway here and multiple floors. When you come up to the northern side of ECS North, there's a large atrium here behind this word engineering. Some of these are large classrooms that you might have in. Over here off to the side, these are the offices for all the teaching faculty. Actually, this one right here is mine. So hi, there I am. Hello. Um, so you can come down this hallway, and usually if our doors are open, we are more than happy to talk to anyone. So it's just a great way to find us. A lot of the other faculty are in research buildings, so they're a little bit harder to get to. But all the teaching faculty that you'll know will be down in here. So I usually have candy hanging outside my door. That's how you can tell mine, or it's just a bunch of magnets because people have already taken my candy. So, okay, that was another long-winded answer to a short question. Sorry. What else? Okay. Yep. What type of candy? Ooh, I have a selection. I actually have four different types of candy. I have the ever important breath mint for, when you're running late into an interview and you worry about having coffee breath, as I often do. I have Dum Dums, so just the basic sucker, Hershey Kisses. And then I have the Sun Kissed Gem, which is pretty much like a hypoallergenic piece of candy. The only thing that it has is it has sugar in it, so it's not great for diabetic, but nut free, dye free, everything free, but really tasty. Okay. On that note, I'm going to stop recording, but I'll hang around for a few more minutes if anybody has any questions. Um, Hopefully this was useful. Oh, let me bring up the slides again really quick. Nope, not from the beginning. Okay, please provide feedback. We really do look at the feedback and the surveys, and it helps us to improve in the future. So it takes like 2 minutes. Really would appreciate it if you just log on there and just give us a little bit of feedback. Was this useful? Was it not useful? How could it be better? That sort of thing. Because we want this to be as useful to you all as it possibly can be. Okay, now I'm going to stop recording. And I'm just going to hang